is a robot operating system. It is a robot operating system where you have node. Node is a sensor node or a robot node or a machine node or something. You have different nodes, and these nodes will communicate to each other. So they will communicate to each other. When you have a communication, you expect two things, right? One is there is someone who talks and there is someone who listens. Not only that, there is also something which has to be communicated. So that thing which has to be communicated could be a topic. Okay, you could call it a topic. For example, now I and we are communicating each other. Our topic of communication is automation and industrial communication. This is our topic. In this topic, I have a message. Now I have a message. My message is to introduce you about robot operating system. This is a message. Okay, now I'm giving a message. These messages are coming to you and you are listening and then understanding, and then if I ask you some questions, you will answer, and or if I'm telling you some information, then you listen, right? So that's how you react. So you have a robot. A robot is a machine system where you have actuators, motor systems, and so on. And you have a controller. Your controller could be a computer system where you are going to formulate some problems, some ways of behavior, motion behavior, how the robot should act, how the robot should behave, and so on. And this will be decided by your controller, and then you let the robot actuator to perform the desired or the prescribed operation. So this time there is a talker, there is a listener. So the listener again could listen and then tell the talker, just tell the master one, just do something like this, or just I follow your command or something. So just to again summarize one more, when you talk, there's a listener, and this listener could have two kind of behaviors. One is there is someone who only listens, passive, just who passively listen. And there is someone who actively respond, just to something that it listens. So now when we look at the robot systems, sensors are, sensors give information about the current information, right? About the environment. They detect their environment and then tell the controller about the environment, information about the environment. So in this case, sensors are just giving information, they are giving information to the controller. But if you see actuators, they listen and perform an action. For example, if you have rotational angular velocity of 20 rad per second, then it will listen and perform the action. Okay, so we have two things. Sensors, they only give information about their environment, and actuators, they give the information, also they perform the command. Okay, so just with this concept, let us go to the robots and ROS. So in ROS, from the sensors, we get information. So we subscribe. Okay, we call it subscription. Subscription is getting information from the world. From sensors, we get information. For the motors, we give the command. Okay, or we publish data. Okay, we publish data. So if you have a talker, just you have someone who publish, and if you have a listener, it is simply subscribing to the information. This is a simple example. Now, just to understand actually in a more detailed way, I would like to go through the environment. I don't expect you to just understand, and I want you only to understand and to get the concept. Okay, just you are not expected today to do the implementation, everything. I will probably use this slide and then get through it step by step. But now to start with, just I will do my own demonstration, just step by step, and then we have the record of the video, and then you will check it later. Now actually the first thing is you have to install your ROS system. For ROS, actually there is ROS.org, where you could get information about ROS. It's for you. Just this is I don't have to teach you. Just this is where you get information about robot operating system. Yeah, in this actually they are very active community, and most of open robots are actually supported.
Professor,
yeah,
is it work for Windows or is it only for Linux?
Now it works for both. Yeah, but I personally prefer to use Linux. Actually, I'm a fan of Linux actually also. So, but now you could use both. Yeah, so now the current versions actually are, there is ROS 1, which is the current version is Neotic, and the ROS 2 version, actually there are two versions now. One is ROS 2 and the other is ROS 1. ROS 2 is actually, it's more designed even for Windows 10, and ROS 1 is actually still, it's native to Linux, but still you could install it on Windows. The other point is, in ROS 1, it is a centralized control. You centrally control everything. In ROS 2, just you will control decentralized, just you control only something that you want. Maybe you could control in a decentralized fashion way. Just if you are interested, just really go through and just read it. This lecture is not, I'm not supposed to teach you everything about this, but if you are interested, just you can get in. Then the other is there are versions of installations. Just check which fits to your operating system. Yeah, for example, here this is ROS 2 and this is ROS 1, and just there are also ROS wiki, maybe just wiki ROS, where you get instructions, how to do things. Maybe you want to know how to install something, or maybe you want information about the robot operating system tutorials and so on. So there are different tutorials at the beginner level, at intermediate level, and at for different applications. So
Professor,
yeah,
I have seen there are two ROS for Windows in the previous slide that you told to download.
Just you choose whatever you like. It depends on the version. It has support. ROS is actually, it is a community support.
In here there are two. One is Galactic and another is ROS Foxy. Which one should we download, or you prefer?
Yeah, actually I will. Actually, personally, I prefer even the earlier version, but it depends. For example, if you go to this, it has some period of support. For example, maybe we go to wiki and we see. Distribution list. Okay, so For example, Galactic is, yeah, just now you see when you look at here, Galactic is stable version, okay? This rolling relay, for example, this is a beta version, okay?
Okay.
Foxy is the earlier version, you know, earlier to Galactic. So, you know, just time by time, just they are updating the distribution. For example, I personally use melodic version because I will tell you that my reason, because there are various robot systems which were developed on melodic, and then later there are other guys who have developed, yeah, just the committee has released the Foxy, and then some of the older robots were not supported with the new one, you know. So
Galactic one.
yeah, I would like to have more robots which were supported, you know, which were developed in the earlier version, and then the guys, you know, these robot companies have not updated their distribution, you know, just they released only for melodic, and then since then they were not working on that. So, but the community was developing some new features and so on, and then later on when you install, you will have some errors, you know, building errors, because it doesn't fit to, there are some, for example, ROS 2, you know, Python 2 was now depreciated. So some guys have developed their system with ROS, with Python 2. Now, when you install and run it, you will have so many errors. So in order to avoid such things, I will go back to the previous versions and run. And if you know actually what you are doing, I mean, once you understand the architecture of the ROS, especially with new releases, with Foxy, for example, then you could be able to edit by yourself. But if you want to use as it is, okay, you have to check the robot manufacturers the release and then just use something which fits with the distribution. Otherwise, you will have some problems, some building errors, you know.
Okay,
yeah, so that's why actually I personally prefer to go to back versions. Melodic one, and I use still melodic.
Okay, Professor, thank you.
Yeah. Yeah, okay, so that's it. And then actually, so you install your ROS, follow the tutorials on wiki, nothing, you know, just here there are different versions. Even the oldest version is kinetic, melodic is the middle one. So here you install, follow the installation process, just install it, you know, nothing else, just you install it. Follow this if you are using Ubuntu or if you are using Windows, just follow it and then install. Then everything will be fine, okay? Yeah, so once you install your ROS, and if everything is done, you have to create a directory. This directory is a directory where you put everything about your file, okay? It's nothing, just this where you put your working directories. So build and the devel are, they are the compiled files automatically generated, so you don't have power on these two things. Source is where you save all your data. Okay, create a new folder. For example, today we are going to see about AIC tutorial. For example, AIC tutorial. This is where I'm going to work. This is my working directory. This is my working directory. Inside this, I will write so many things. Maybe I want to now, maybe I will create some code, for example, maybe say just open, maybe save in Katkin, sorry, in Katkin workspace, in source, AIC tutorial, and then name it, this is publisher, or maybe we start with subscriber, maybe subscriber, driver, tutorial, nothing else, .py, nothing else, just you save it. Now you have something to write now. So now what shall we write? Maybe just let's say import system. You know, now this is a Python command. I am using Python command. Import something. Just now we will come to this later. But I was to tell you that you create your folder. This is your working directory. Then we create other files later on. Now, the first thing is you have to launch ROS. Launch ROS with ROS core. In this, you see something. Here, you see something which says logged into my local directory. Then it creates a server. With this local server, you can connect to any network, you know. This is my local server. My distribution is melodic. As I said, I use the older version. This is starting, okay? So this is node is created. So a ROS node is created. It is a master node. Then I could do anything now. Now just we can do anything. Then the other is just create a new tab or maybe a new window here. Actually, there are some additional things actually that you have to do. You have to source your directories actually where your local folder is. So I have to source everything, but this is already available on the when you install, you will see these things. So this is not really a big deal, and you don't have to worry about it. It's already available. Now what is very interesting is now we created a ROS node. A simple exercise actually, which is very interesting, is to go to some tutorial, embedded tutorials. Okay, so we have turtle sim. This turtle sim is start, you know, it is like hello world. Okay, it's hello world where you start a simple exercise. So here there are some versions. Maybe I will run like this. Just I don't have to do anything. Just I will copy this one and paste it here. Then I have now new window. This window, this is nothing. Now I see turtle here. I see a window. Nothing else. Nothing happens. It doesn't move. It doesn't just, you know, nothing happens now. Now I said in ROS we need a topic, okay, to talk about. Now we have a terminal here. We have a window here. Now we would like to create a topic and communicate with this turtle robot. So how? Maybe we say, maybe just ROS topic list is how to check available topics, okay? Topics. With this robot, ROS out and ROS out AGG is the ROS core. You know, when you start, it is it's signed in. You know, you started, you launched the ROS is already launched. So this is nothing. You don't have to do anything with this. But turtle, with turtle, we have 3 topics. First is command velocity. Second is color of the turtle. The third is the position of the turtle. So we can talk, hi turtle, where are you? Then I am at x10, y5. Is a position, right? Turtle, move 5 with 5 meters per second in x direction. Now it is velocity command to let the turtle move. The velocity command is publishing, pushing the robot, just moving the robot, and turtle pose is getting the position of the turtle, okay, the current turtle position. So we have interesting topics, which is position and command velocity. Now, actually, the very interesting point is here is now you could really access the details of the robot. Now, if this turtle is a mobile robot, you know, if a mobile robot, now you get access. So now maybe let's say ROS topic info about turtle 1. Then maybe command velocity. Maybe you are interested to know what is this command velocity. So you see now there is a geometry message twist. Now this is a standard. This is a standard message over TCP. Maybe if you know communication over TCP, this is a standard message. Now I will copy this one and maybe Google it here, and then I will get something, you know, here. So geometry message is a twist message which has a vector data, vector 3, linear and angular. Linear means vector 3 linear means x, y, z linear motion and x, y, z angular motion. That's physics. Okay, nothing else. Now this physics. So this is how you prescribe to the message. The message is 3, vector 3, x, y, z linear and x, y, z rotational. Maybe here I could say ROS topic echo, then command, just the topic name. Maybe I will copy this one and paste it here. Now I will see what is the message. Now nothing is displayed because it is doing nothing. It's doing nothing because I didn't publish any data to the robot. Okay. In order to able to publish, maybe I will create maybe a keyboard controlled function. Maybe there is actually built-in keyboard function. Maybe if we go here to turtle sim, maybe we will find yeah, actually, if we don't see it immediately, I have actually the tutorial for you. So what we should use is ROS run turtle sim turtle teleoperation. So we have to write this one, and then we will get the turtle sim. No, ROS run first. Sorry, ROS run turtle sim turtle one teleop, maybe okay, like this. Maybe I made a mistake. Turtle sim turtle teleop key, turtle teleop key. Then sim ROS run turtle sim turtle turtle teleop, maybe the turtle teleop key.
Doctor, is it something to be submitted or only to learn?
Sorry?
Do we have any assignment to be submitted or it's only for learning?
Your sound is actually, the quality is not good.
Yes, do you hear me now?
Yeah.
Do you hear me now, Professor?
Yes.
I'm just asking, do we have any assignment to submit or it's only for learning?
Yes, it is only for learning. As I mentioned earlier, just during the starting of the discussion, during the lecture, when we started with the lecture, we said you told me to give you the both options, with process simulate and to show you with ROS as well. Yeah. And then you will get overview of all. So it is.
I think it's so important. Do you please want to record it? I want to.
I'm recording, and you will get it later on.
Okay, thank you.
Yeah, I think this is very important. If you, for those of you who want to work on research for your future, it's very important because I know how it's challenging, for students.
Yes. Would you please upload it, Professor, after finishing, or?
Yeah, I will upload this.
Okay, thank you so much.
ROS run turtle sim turtle teleop key. Maybe here. ROS topic we have. Maybe I make this one. Stop it here. Turtle sim turtle one teleop key. Maybe just let's check it. Then maybe we copy it here and maybe just check what is missing there. Okay, turtle sim turtle. Okay. Yeah, I don't know what was the mistake. ROS run, turtle sim, turtle. Turtle one. Okay, sorry. Okay, anyhow, now we have a keyboard input. Okay, this is keyboard input as it is now. Look, whisk forward, then I will rotate, then move, then I will rotate, move. I'm controlling with my keyboard. Okay, nothing else. I'm controlling with the keyboard. Now, maybe you are interested to know this. Now, actually, I will make this detach it. Here is my control with mouse. Now look. Now you see the data, right? Here. So this is a data that we are subscribing. So as I said, there is a topic message. The message is linear along X, Y, Z and angular along X, Y, Z. That's what we want actually from a robot. So from the robot, then you get data. Now, this data is generated from this turtle scene environment. And then we are getting the information. Okay, if you know this, then maybe you want to, now we subscribed, we get the information, the pose information. Maybe you want to visualize it also on the graph, okay, what the data is. That is easy. Actually, ROS has a support RQT. It is a graph display where you could, see the data, actually, the position, velocity, and so on. Now, for example, here you are looking at teleop is input from the keyboard. Teleop is a topic from the keyboard. Turtle sim is this blue environment. ROS topic, it is the subscribed data that we subscribed it here. Okay, it's a subscribed topic here. So it is a message created here. So now we are getting information from teleop, and this teleop also generates a topic. Okay, generates also a topic. Now, for example, if we make like this, in turtle one, there is a command velocity topic, and this velocity command will go to the turtle sim simulation, and this topic generates a message which is linear X, Y, Z, and angular X, Y, Z. Here you see the display. Now you see the display for each velocity, linear angular velocity, as well as X, Y positions. Now, if we control this robots, you see, look. Look it. Now you see the data is changing. So now you could visualize it even. Actually, then it's very interesting, right? It's very interesting. Okay, now just leave this. Let us leave this one. And now just let's see something else. Something else. Just let us see how to publish. Now use now actually how to do what? How to make subscription, right? Now you know how to get data from the subscription. Subscription is echo. From ROS echo, from ROS echo, you know how to get the data. Only echo gives you the data. But now you may be interested to know how to command the robot. Now I'm getting data, but you may be interested to know how to command it. It's easy. ROS, just then you say actually ROS run pub. Here I have the code. Here you say ROS topic pub, and then you give the topic package, topic name, then the message type, then the specific data you want to control, and then it will perform the operation. Okay, so according to this command, what I have to do is ROS topic publication pub, then what is the message, the topic now. What is the topic? The topic is, just if you want to see the topic list, there's nothing else. Maybe detect this one and come here and then say ROS topic list, ROS topic lists. You have turtle1 command velocity. So this is my topic list. My topic list, I will copy it here. Then I make space, one space, and then I need message. What is the message type? So to know the message, I will say ROS msg show, then the command name turtle-c. Then I will see the maybe this. No, actually it's not like this. ROS topic. First we get to info of this guy. It is geometry message twist. So from the geometry message twist, I would like to get this one and paste it here. And then I will say open quotation mark, the linear, and I will make tab, okay, to complete. Now it, you know, when I make tab, it makes display. Now I will say, I will use my left side arrow and they say, I want to move along x-axis from the current position. How much distance? Maybe 3. Then enter. Yeah, you see?
Professor,
yeah.
Is there any z-axis?
Eh?
Is there
No,
any
no.
z-axis?
Z-axis,
So
no. This is generic, you know, that's why. Z is nothing because we are only in X and Y.
Okay.
Just this is only, this is common, you know, you assume 3D space, but Z is 0. Now let's move this, let's rotate about Z axis, maybe 3. And enter. You see? Wow, very interesting. Maybe again Control C and then again maybe make along Y axis also 3. You see? Very interesting. Again, maybe Control C and then maybe say this is 10, maybe, let's say. Yeah, wow, that's amazing. Then maybe I will say again C and then maybe leave this one 0 and sorry, maybe say it's maybe we'll say X is negative, maybe just let's say, see if it negative works. So it is, maybe I will use my cursor and move the robot a little bit up higher. Maybe I will keep the robot here just to able to see, or maybe a little bit, why not? Then maybe I would say my keyboard control was make it, unfortunately. We'll make use it here now. Okay, now it should work. Now I will make it here. Yeah, maybe just. So just let's keep it here. Now I will go to my pub and maybe negative workers. Okay, we saw it. Maybe here we make 25, maybe 50. Okay, let's see what will happen. Yeah, wow, amazing. Okay, that's amazing. Now maybe we make this, and then y, if we cannot rotate actually along y and x because the rotation is only along z axis. You know, just the motion of this robot is move. It could move along x, y, not along z. Also, it cannot rotate along x and y, but it could rotate along z. You know, it is steering. You know, that's one possibility. Now, actually, what could be very interesting, you know, is not to control through the command terminal, but to control this robot through the script. If you're able to do that, then the world is actually yours. Yeah, I mean the world of robotics actually. So now let us go to our subscriber, and then I will, we will talk. So whenever we talk about ROS, you know, what we have to know is one, we need ROS Pi for Python. If you are using ROS Python, if Python environment, you have to use ROS Pi. Okay, then the other point is from this message, actually, we have geometry message twist, right? For the geometry message twist, when we check it online, it is from geometry message is actually from, yeah, it's from, in geometry message, actually. In geometry message, we have acceleration with timestamp. We have acceleration with covariance, acceleration with covariance, stamp, timestamp, inertia stamp, point cloud, polygon, everything, quaternion, transform matrix, quaternion stamped, vector 3 stamped, and range is force or torque. All these informations could be accessed, okay, through the geometry message. So we need to import the Python version of geometry. So maybe we want only twist from geometry message. Just what you have to do is only take this one, geometry message, this one, okay? From this geometry message, import only twist, okay? This API, in the geometry message API, you have what? In geometry message API, you have twist. So import geometry message, from geometry message, import only twists. We don't care about others. Now we have access to geometry message. All messages on geometry could be accessed. Now just define your callback function. Define what else do you want to say? We want to access, define callback. What? We want to get information. We want to subscribe. Okay, we want to get information from this echo. We want to get linear and angular, right? So call back get pause maybe, then data. Then you have to write some function. Maybe I will have a previous one. There's nothing fancy. We say if we want to get the information with some string, okay, so we can take this one. Maybe we paste it here. ROS Pi log info is just information. What time? Maybe for this we need to import date time. Then from date time we get now. What's the time now? Then subscribed data at S is the time now. and we get data. So this is callback, just simple callback. Then we need a main function, which is, maybe I will copy this one and I will explain it for you. This is a main function where you have initialized your ROS and the subscriber. Listener is just this simple. You can put some identification name, okay? Just doesn't matter. But this is a topic name. So to get this one, you have to say here, you have to get the topic list, right? You have to get the topic list. Maybe you say, maybe here, maybe I will say ROS topic list. I will get CMD velocity. I will copy this one and I will replace it here. This is my topic. Then from the topic, what do I need? Then I will say ROS topic info. This, it is geometry message. From the message, I need only twist. So I will take twist here. Then callback is, actually it should be callback pause here. I will put callback pause here like this. Then listener function will be called in the main function, and then spin is just iterate every time, and then finally I have everything. I have everything. Now I will say this one, save it as it is, maybe for you to remember the subscribed data during AIC lecture. Something just could be. Then here I will have to go to the directories, then cd cat king, then C, then I have to go to source, then check where is it. It is in AIC tutorial, cd AIC, change the directory to AIC tutorial, then get here. It is subscriber tutorial py. I could run now with Python subscriber tutorial, and then run it, and it says cannot from geometry message import twist, cannot import name twist. Okay, what is a twist? Geometry message. Yeah, sorry, I missed something. Sorry, geometry message dot message. Yeah, that's my mistake. And now it should work. Principle. Yeah, now there is nothing to subscribe. So to subscribe, I would like to move this one with my cursor. So maybe move detach. Look at here. This is the data and this is the robot. Now look at when I press my cursor, it will show you. You see? You see? Now, what I mentioned was the subscribed data during AIC at linear and at angular is this. So I got I'm able to control to get my data from the robot with the script. Wow, that is amazing. Then I could say maybe this is maybe you want only to get only data, right? Maybe you will say you don't want to get all this information. Maybe I will say this is too much. Maybe you want to get only some information. Maybe I will say the data, what do you have? Data dot linear dot x. You want only to get the information about x-axis. And now look it, I will go to my folder here. This is not that one. Where was my script? Sorry, my script is here. So I will go here, then say Python subscriber tutorial. And now I will like to display. Okay. Yeah, so now let us look at here. I will go to here and then you see, now I'm getting only the x-axis. You see, only x-axis. Now for you, just simply to understand it, I will go to subscriber, linear x, maybe I will say only linear. maybe you don't want this ROS pi info, log info, you know, maybe you say print, maybe you say, because you are more preservative and then you don't want to have all this information, then print data linear x, and then remove this one. Maybe you are confused with ROS pi info something. Then what we could get now is a little bit different. We don't have to get this information now. Now we get only here, make it here, and then put your robot here, display, put your cursor here. You see, now you don't have any information which are confusing you further. Okay. Maybe you want to do something. Maybe you want to do something, you know. Then maybe you want to do some operation here. Maybe if data linear x equals to 10, maybe you say reached. Maybe you want to say something like this, and then we have to make this one, stop it here. Yeah, I'm not sure if we could achieve 10 now. We make it this one, we make our robot here, and maybe just we simply move the robot and see. I think 10 is too much. Maybe I will say 3. What? Maybe 3 doesn't work. Okay, so maybe, yeah, just maybe now, just to go with our time, just take your time and just you can, yeah, just spend some time just to get this one. But what I would like to do now next is to show you actually how to publish again. Linear, and maybe X is this what something we want to publish. Actually, then what you have to do again is also just you make new, save at the same folder. Maybe you say it publisher .py. Maybe we need ROS import. Still, we need import ROS pi, and we need maybe also the same thing in from geometry message import twist. Then what else do we need? Maybe we don't need anything else. So just to be fast, I have some tutorial, the previous tutorial, which is Docker, which we call it, we could use it here. Then I will explain for you. No problem. And now here maybe Yeah, maybe we need systems. Yeah, maybe we make take system. System is from your computer. If you want to access a folder from the computer. Now what we have to do is, we need a ROS publisher, and nothing else, just the same thing. The ROS topic, then the message, and then the frame rate, just the refreshment rate, and then you have ROS rate here that's already defined. Then I say velocity is a twist. Take the twist, twist is this one. From then while node is, while the ROS is running, velocity, this velocity of linear x equals to linear velocity. Linear velocity is input, okay? The velocity dot angular z is angular velocity. This angular velocity is again also input. Now this move function will take input of linear velocity along x and the linear velocity along y, because angular velocity along z. Rotation is always along z. Linear movement could be along x or along y, but I want to take only x just now for showing you. So this is only to display the data if you want to display on your terminal. And then the most important thing is this one. Pub is publishing. Pub dot publish what? Velocity. This velocity is changed to linear and angular velocity, which was input to the move function turtle. Then call move function turtle, take input argument and convert to float. Take the second input argument and convert to float, and then move the robot. Now we run this and let's see what comes out. Now I will make this list the folder. Then I will say Python publisher. Maybe I will make tab and then I will complete it. Then I have to give inputs. Okay, system input. So what's my input? My input is the initial could be linear velocity. I could say 3, and the next is angular velocity, which I could say 0 and C. What will happen? But we have to open the turtle sim simulation because we will see when the robot is moving. Okay, so now enter the geometry, no module name, geometry message. So that is a mistake. Geometry. Oh, it is my spelling mistake. Save it. Then again, run it again. While we are running, just we have to look it on the picture here. Then run here. Yeah, because it couldn't move to the positive. I have to make it to negative. Maybe now I don't have to go to the script. Maybe I could say here minus. I guess now you see the robot is back. So it is continuously because of the this one, here spin. Where is the spin? Yeah, here there is a rate at every 10 frame per second. There is updates. Okay, so every 10 frame per second there's update. So the robot is always moving, but now it reached to the maximum. And now I will cancel it. I will cancel this one now. And actually the maximum, yeah, is already there. Now maybe I will say it is 3 positive. It is now moving back. That's amazing. Maybe I will close because this is too much now. Maybe I will close and yeah, maybe launch it again because it's too much. I need clean space. So I will go here and then maybe say it's this. Then it's maximum. So I have to make it minus to go to back. It's going back. Now I'm controlling with Python script. It's very amazing. Now I will make this one, stop it, and then I will change my data. Maybe here I will say it is 3, maybe 1, then maybe 1 again. You know, look, oh, amazing. It's amazing. It's making something like this. Yeah. Wow. It's amazing. Yeah. So it makes always the circle. So I would make this like this, and then maybe change this one. Maybe I will rotate only the robot 0, and maybe rotate the robot to 2, maybe. Maybe I will stop when it is in the beta. Okay. Yeah, you know, the point is when you click stop, Control C to abort, it doesn't stop immediately because it is a velocity. The velocity doesn't go to 0 immediately. You know, it needs some time because you are accelerating. While you are accelerating, if you press stop, it doesn't stop immediately because the velocity is at the maximum. It needs some time to slow down and stop. That's the problem. For example, look it. Now I say I start. Look now. Now I press stop, but it's not stopping. It stops later. So that's why we need a velocity profiles, which lets the robot to gently, you know, stop when you have to brake in case of emergency, for example. So this is really amazing. And yeah, now you know, you could able to publish to a robot, and you could able to subscribe to the robot. Now, just the good thing, the next point that is very interesting is you could connect from ROS. For example, I have recorded data from the real robot. Maybe I have shown you last time. CD Katkin. Just now I will go it to its rule. Yeah, CD CRC. Then ROSbag is actually ROSbag is a service where you could store your data. Where you store your data as it is. Okay, you can dump all the informations from the real robot into your local folder for offline post-processing, maybe later on if you want. So I have ROS data as it is now, ROSbag play. For example, if you have optical sensors which has to capture the scene, you know, in your workplace, and if you want to process it later on, you know, you can use ROSbag, dump all information on your system. Maybe it takes lots of memory, of course. Then later on, you could process it, you know, offline. Now this data is actually running as it is, as it was running on the robot. Okay, this is the data which was running as it was in the robot. Now, if you see the ROS topic list, I have now additional ROS topics, which is not in Turtle. Turtle is Turtle. Okay, just now forget Turtle. These 3 forget. Others are a universal robot, which have additional information about motherboard, about robot status, about the range, torque force, about transfer functions, about the velocity, tool center point, about the joint temperature, about the joint state, about the trajectory, and so on. Lots of information are now stored here. So now, for example, just if you echo, ROS topic echo, for example, joint states, you have this bunch of informations for each shoulders. So now just you may be interested to visualize this one in Gazebo, or maybe in Unity 3D environment, or maybe in Unreal Engine, or anything, you know, where you think that it will visualize your system. Now for me, actually, I'm really interested to visualize it in Unity 3D, actually. I'm very fan of it. And then this is actually my robot. Now, actually, I will show you. This will run what is simulated here. But before that, actually, I have to know something about my IP address from the virtual machine. Maybe I will say if config, and then I will see information. Then maybe I will copy this IP address, and then I have to use it in my Unity environment. I have here a subscriber to ROS. In the ROS subscriber, I have all this information, and I have a robot here, and this robot is connected to my IP address. Okay, so the IP address is already. I will copy and paste it here. No, sorry. Unfortunately, it is correct, so I don't have to do anything. Maybe what I have to do is I have to run, and yeah, now ROS IP is not connected now. Not connected. It is not connected because of 15610. Okay, yeah, I know. Actually, it's not connected. Yeah, actually, I will run the other connection. Yeah, I have to do something. Actually, ROS launch. Then file server, then ROS chart communication. I have to initialize the communication between the robot and the Unity. Actually, that is what I have to do before. Then here my IP is 101. I have actually two versions in Unity, so I will show you this one, 101. And I will communicate through the port 9090 to the robot, and I will subscribe to joint states, And now, if we see, we have to now get the robot, okay? So we have to visualize the robot now. So now the robot should be visualized. Yes, perfect. This is what the robot was doing. This is the actual data. It is not a simulated data. It is the actual data that I have captured from our real robots, and now it's making the movement of circular operation, and all the informations, all the information that you see here. These data are being transacted in real time. They are being transacted in real time to this Unity environment. Now, why I said important was here you have a real data to the robot from the Unity environment. You could do whatever you like, and then let the robot do the operation by publishing to the robot and subscribing from the robot. This is a digital environment where you subscribe the data from the real robot. But if you have a control, you could also implement your idea onto the robot, and then you are free. You have really exclusive freedom to control over your robot, about the property behavior of the robot. But be careful, you are the only one who is a master of the robot, so you have to be very careful. You have to be cautious. If always your hand has to be with the emergency button, because if you type in by accident some wrong number, then the robot will make a magic motion, right? So when you publish, especially when you publish, you have to be very careful.